today is Ian Lewis. He's the developer advocate for Google, based in Tokyo. And his talk today is about Go's plugin system, getting plugged in with Go plugins. Just give us a moment while we get set up.
So today I'm going to be talking about Go plugins in 1.8. So Go plugins are kind of a new feature that I think are pretty interesting, and I hope that you are too. So you might be thinking to yourself, I know Ian, but I've looked at the plugin interface for the new plugin package, the documentation, and it's just two types. And one of those types, there's one function and one method. How are you possibly going to spend 20 minutes talking about this new API when it's so small? But bear with me. Hopefully, I can give a little bit of context and some of the past and prior artwork or prior art for plugins in Go, and some of the reasons why you might need this, and also some of the kind of use cases where you might use something like plugins. So going back in time to Go 1.5, Go 1.5 introduced a new kind of shared library feature that allowed you to dynamically link libraries together in Go. So normally in Go, when you compile a program, it's statically linked. So you can then copy the binary around very easily without having to worry about whether the dependent libraries are installed. But that didn't really work so well with things like Linux distributions and places where you actually do want to reuse these kind of shared libraries. So Go 1.5 added this new shared library function, or shared library feature, and you would basically enable this by using this this build mode option, and you give that you say build mode shared when you compile a program, and then you can actually compile a shared library. So you would basically write it the same way as a normal Go program, but you would just basically not include a main method. You would write the functions and types and variables that you wanted to expose via your shared library into a file, and then compile that using the build mode shared option. So here we have like just a simple example where we of a calc shared library that implements this sum method, or this sum function. And then we can actually, so when we build that, we have to use this build mode shared, and we also use this link shared option, which will then cause it to dynamically link. But one of the things that you have to remember when you do this is first you have to build the standard library as a shared object, or a shared library. So you can then link to the standard library. So once you do that, you can then build your own shared library. And then it's pretty easy to use it. So from a program, you can import it just like any other module. So here we're just importing this calc module that for this example, and then calling calc sum on it. So it's like any other kind of standard library or other type of package. But you have to remember that when you want to build it and actually take advantage of shared libraries, you need to use this link shared option. So let's kind of look at this particular example. If we look at this calc function, so actually I need to go to this one, calc. We can go build mode shared, link shared, in order to actually build this. And so now it's built it, and what we can look at is that under the package directory in our Go path, there's now for our architecture, there's a dynamic link directory. And under here, we can actually see that we've got our new calc library. So here's the archive file, this .a file, and this libcalc.so, which is our shared object file. So that's kind of like you would expect from a normal kind of shared library, right? So then we can go to Go source cashier. So here's our program that utilizes that library. And we can say, we can look at this, and it's the same exact one that's in the slide. And then we go build. You can actually, if you do a regular Go build on this, it'll actually work. But what this does is it actually builds a static version of our executable. So this is not actually what we want. What we want to do is go build link shared, which will then build it as a with dynamic linking. And then if we do LDD again on cashier, we can see that it's now linked to our standard library as well as the libcalc shared library. So this is great for things like Linux distributions where you're going to distribute the libraries and the actual programs that use them separately in separate apt packages or yum packages. But it's not so great for normal applications, and it's not really flexible in terms of kind of dynamically loading any type of shared object file, right? We kind of have to know up front which libraries we want to use. So let's actually go back to the slides. So this is basically good for, like I said, using a shared library, but you need to know it's not very terribly flexible for things like, the use case of a plugin, right? So that's kind of where the new plugin package comes in. So the new plugin package gives us a new build mode. So much like the shared mode, we just change that to plugin, and we can kind of build our library as a plugin instead. And this basically allows us to dynamically load a shared library, and it can be loaded very flexibly. We don't have to rely on a dynamic linker. So there has been some prior art for this type of thing. So one of those is, say, exec plugins. So basically, up until now, the main idea was that you would have to build another process or another program for your plugin, and then communicate with the main process using some sort of API. So normally what you would do is, one of the examples of that is one of my colleagues, Kelsey Hightower, wrote a certificate manager for Kubernetes, which will automatically renew certificates, right? And it uses Let's Encrypt. And one of the ways that Let's Encrypt will do the verification of your domain is to have you create DNS records for that domain and then verify that those records exist so that it can verify that you own the domain, right? So what he wanted to do was have a backend where you use an API to update your DNS records and have that do that automatically. But you could use any number of DNS providers. Like you could use Google, like Cloud DNS, or Route 53, or Gandhi, or any number of backends. So he wanted to make that pluggable. So he created this kind of exec plugins style where you actually exec or shell out to another program. And what happens is like you give it when you shell out, you give it a number of environment variables and some data on SDN, and then that program then returns a particular error code based on what happened, right? So this is kind of like the API between the plugin API that he had going on here. And so you could write programs that would conform to this, but it's a little bit clunky, right? And then there's also HashiCorp plugins, and these are kind of a similar concept, but instead of doing a shell out and using basically the SDN and SDL pipes, what you would do is use RPC. So here it uses uses gRPC to make kind of regular function calls. So it's much similar to a plugin interface, but it's still actually shelling out to or still creating a separate process that you have to communicate to. And one of the problems with this is that you have to then, if you're say working in a production environment or you're working in some sort of environment where you need to care about these plugins and make sure that they're up all the time, you have to monitor them and make sure that they don't become zombies and all kinds of other things kind of come into play. So it's not really ideal for all scenarios, right? So that's kind of where Go plugins are, or one of the reasons why they were created. So in order to actually write a Go plugin, it's very similar to the previous examples, the shared libraries, in that we basically create a package without a main function. We don't need a main function. We just define the functions that we want and variables that we want to expose. And then we compile that using the go build with the build mode equal plugin option, right? And then to use that, we actually just use the plugin interface. We don't actually have to use a dynamic linker. So all we have to do is add in give it the path to the SO file that we built using in the previous step. And then we can then take the returned object, so in this case it's a P, which is a plugin object, and then call lookup on it to actually get the values that are part of our package, right? And these come back as an interface type, which we can then cast into the right types. So down here at the bottom, we're actually casting the V to an int and the F to a function, and so we can assign values to variables and call functions and things like that for our plugin. So this is actually pretty easy to use. So like when we actually build our main application, we don't actually have to use link shared or any other type of object. We just build our application normally this way, right? So we're not using any sort of dynamic linker. It's completely, it's even more dynamic than dynamic linkers. So if we go and see what this actually looks like, let's see. Plugin. So in here we have our little adder plugin, and what this does is just a simple kind of hello world example. So actually, let's cat this. So here we just have that previous example. We have an F function and a V value, and in our main program, we're just going to set the value to 7 and call the function. And that's just going to print hello number 7, right? So if we go to the plugin, we go build, build mode, plugin, we can get our SO file in that directory. And then if we go out here and we build our app, we can have our adder function, and we'll notice that this is just like a regular build, like we're not dynamically linking to anything. And so if we call adder on this guy, it'll load our plugin, set the variables, and call the function in order to print the number 7, right? So this is simple. We can kind of see that it's actually working, but that's like a very, not very useful example. So like, there are a number of use cases that I can imagine for using something like plugins. So one of those might be if you're distributing an application where you're not actually distributing the source code. So say something like a closed source application where you want to give users the ability to extend it by providing some sort of plugin API. You can do that using plugins, but also for things like abstract backends. So like the certificates example that I was talking about, or the DNS backend plugins. So things like cloud providers or different implementations of backends. So those type of use cases are the ones that I think are probably the most powerful. So I created a separate demo for that. So what I did was I created a file demo here. And what this is actually just using a plugin interface to define how to write a file or a blob piece of, basically write a file. So like we can say write this to S3 or write this to Google Cloud Storage or write it locally to disk or however we want to implement this, right? So what I did was I implemented a couple plugins. So if we actually look at the main function and what it does, we take a plugin path and a bucket and a file path. So this is the file path to the file that we're going to write, and this bucket is our destination, and the plugin path is just a path to the SO that we're going to load. So the shared object file. So here we just call plugin open on the plugin path. We look up our write file function, and then we call write file on the. We open the file and then we call write file on the using the bucket and the file name and passing a reader to the local file. So here we're just actually going to write the file or call the backend plugin to do the actual writing of the file, right? So we also have, so what I did was I created a simple example of a file plugin where we write it locally. And so what this does is just uses the bucket as the destination path, and then copies that file, the given file, to the destination directory. So we can see here that we just create the destination file and call IO copy on it. So if we build this, we get our SO file, and then we can say go build for our application, and then we get our file demo app, which we have our bucket file and plugin options. We give it an output directory, then we're going to have this test.txt file, and we're going to give it the plugin, the file plugin that we just built. And if we do that, we can see that the test.txt file that we have locally here has been copied to the output directory, right? So that's kind of a local, the local case. But we can also do something like an actual backend where we write to, say, a cloud provider, which will give us other things like, you know, redundancy and things like that. So maybe you want to implement it as using like something like GCS. So I'm pretty biased because I work at Google, but what I'm going to do here is write to Google Cloud Storage. And so very similarly to writing locally, what I'm going to do is create a new client for Google Cloud Storage, set the bucket and the file name, create a writer, and then just call IO copy, much like I did locally. So this is going to actually copy our file to cloud storage as a backend. This takes a second to build. And then we get our SO file, and then we can call our function per normal. So what I want to do is kind of verify that the bucket is empty. So if we go here, we refresh this, we can see that there's no objects in the bucket. So then I've run through this file demo, and actually I need to provide the authentication. Application equals service account, file demo, and then we give it the bucket, ultimate Hydra test. Then we give it the file, and the plugin equals GCS plugin.so. So we can see here we're basically invoking the program the same way, but we're just giving it a separate plugin. And if we do that, it should write our file to our bucket backend, right? So this is kind of cool because you can imagine that we could write this file any way we want to. We could maybe make another type of local plugin that would say write the file locally, but write it in an encrypted format, or do things like write to S3 or some other cloud provider or some other provider that that we didn't even think of. So this is a really cool way to kind of extend applications in ways the original author or you might not have actually expected. So to kind of wrap up, there's a couple of shortcomings to actually using the plugin API. So like I think that it's very, it's super useful and easy to use. It's a very simple interface, which is very Go-like. And so I think that a lot of people will want to use this because it's very easy to load these kind of plugins at runtime. You can provide it like as an option to your users on the command line or whatever. And it's also a single process that you have to monitor. It's only like the main process. You don't have to start up multiple processes and make sure that they're running and monitor them. But there's a couple of things that are downsides to this. So when you load a plugin, the plugin is actually built with a pseudo package name. So that package name, when it gets loaded into your Go process, is loaded like a regular package. So you can't actually unload that package later, right? As Francesc would say, one simply doesn't unload a package. So there's no things like hot reloading. You can't reload your plugin over and over again, or reload new versions of your plugin. You could theoretically load a new plugin with a different package name, or a new version of your plugin with a different package name, but that's not really ideal because your old package will still be kind of loaded into the application, and you'll get a lot of package cruft. It's also fairly new, so there's possibly some stability requirements. So like as we were testing this during the release candidate kind of phase, there were a number of bugs that we kind of noticed. So here's a couple of them. One was that you can't make HTTP requests in the plugin because it would come back with a error saying that there was a bad MAC SHA, or a hashing check. Another one is one that Francesc noticed, or both Francesc and I noticed, which is that if you actually try to reload a plugin, like I mentioned, you can't reload the same package name multiple times. But if you actually try to do it, the application panics instead of actually just returning an error. So that's not ideal. So there's a couple of, it's fairly new and somewhat unstable new feature with Go. So if you're just distributing, say, a local utility that people run on the command line, that might be still okay for you. But if you're deploying something, say, like in a production application, maybe you might think about waiting until 1.9 and until it gets a little bit more stable. So just to kind of wrap up, during the conference, there's been a couple of, some talk about making contributions and what the best way to make contributions to Go is, and to Go projects. And I think one of the morals of the story that I learned when I was playing with plugins is that testing is actually a type of contribution. So you don't actually have to write code necessarily to the project. You could test the release candidates for new versions, test the new features, and see how they work in edge cases and stuff like that, and provide feedback. So create issues and kind of engage with the developers. And I think that that's an even better way than trying to do things like fix spelling mistakes and things like that. This is actually something that's really, really valuable to the project. And then, as far as plugins are concerned, to provide ways, think about ways to extend your applications to allow your users to have more flexibility and to extend it in ways that you didn't actually think about. So for things like these, like back-end file writers or other types of things, like this plugin API might be very useful. But also, like, kind of know the trade-offs. You may care more about being able to do hot reloading, and so maybe still running this or using a separate process and then communicating over RPC is better because you can just restart the backend the backend plugin process. But if you really care about just keeping it as one process, then maybe the plugin API is for you. So thanks a lot. That's all I had. Hope that was useful. And we might have like maybe a couple minutes for questions.
Yes, of course. Thank you so much, Ian. Audience, questions? I see a couple of hands. Lots of hands. Okay. I'll just go in order then. Can I get a couple of mics in that area, please?
Hi. I had this question about type information. When a plugin is loaded, the type information would be, any runtime type information, I'm assuming, would be modified.
Right.
There is no type information in Go? There is, right? I mean.
So what happens is when you do this, if we look at the, if we go back to the very beginning here and look at the index here, when you do a lookup, it returns this symbol type, which is basically just an interface type, and then you can just cast it to the right value. So here, later, when we're actually doing that, we can cast the values that are returned from the lookup into the right types.
So we still have to know the type, the right types,
You need
right?
to know the type information. It's not just a generic type that you can interact with.
Okay. Okay. And do you foresee the inability to unload plugins to go away later, or will this be something that we'll kind of live with because of how it inherently works?
Yeah, possibly. I don't really know much about the internals about how like packages are loaded into a Go application. So I can't really say there like what the feasibility of that is. But I can imagine that the API itself could be in the future extended to have like say an unload method for the plugin that you could call to unload the plugin before you reload a new one. That's certainly possible.
Thanks.
Hi.
Yeah.
Plugin support is currently restricted to Linux. So do you know why Windows was not an option?
Can you repeat the question?
Currently, plugin support is restricted to Linux.
To Linux, yeah.
Yeah. So why is it? Do you have an idea why Windows was not an option for this release?
I think that it's mostly because of the way that the shared libraries are implemented. So I think previously the shared library support was mostly done to help with package distribution in Linux. And then the plugin API like reuses a lot of the ways that the shared API or the shared library parts work, and that was all kind of based on Linux. I can imagine in the future that they will support Mac, but I don't really know any of kind of time frame for when that might happen.
Yeah. Is there any plan to add like versioning information, encode the version inside the package and be able to query it?
You can certainly do that with like say a normal variable, or like you could have a function that returns the value, the version for your plugin. There's nothing stopping you from doing that. Is there something like that, a use case that you're thinking of that would require it to actually have a version as part of the API?
I may not want to load like, a lower version for a plugin, something like that.
Yeah, I suppose so. But I think that most of the time, what you would probably want to do is just like kind of handle versioning yourself in their plugins. But I think currently, at least, like it's not really designed to load more than one version at a time. So I think that would be something that could possibly be added in the future, or they may think about in the future more. But this is really more just loading a single version or a set of different plugins in the background, but only loading a single version of them and not actually reloading them or loading multiple versions.
Ian?
Yep.
Hi, here.
I can't see you.
My question is
Okay.
Is related to the concept of shared object itself.
Okay.
So one is there any facility to control access to the symbols inside the shared object? And second is if you can draw parallel between the C shared objects or the DLLs versus the Go language shared objects, what similarities or what differences that you see?
Yeah, I don't believe that there's any way to really restrict the access to the variables. Definitely you can, when you create the plugin, anything that's used internally in the plugin, you don't have to expose. So like anything, you can't call a lookup here on an internal value. You have to have, in the kind of the Go parlance of exporting a value, right? It has to be something that has starts with a capital letter. Anything that starts with a lowercase letter is going to be private to that package, and you can't actually export it. So for things like that, you can kind of restrict the access to them. But like from a security standpoint, when you load a shared object, it's like loading a shared library. So for the most part, all bets are off. You need to like take that into account. If you really care about that, then perhaps like using the old model of creating a separate process and using RPC or something like that is better for you.
Thank you.
Hello?
Yeah.
Hello? Yeah.
I think maybe we have time for one more question or something.
Hello? Yeah.
Where are you?
Where's the speaker, please? Can you, a bunch of hands going up, can you stand
Okay,
also?
there
Yeah,
you are.
thank you.
Yeah.
why, like, if I have option to use a shared library and plugin, like, I think so the shared library will be more useful than this, because here we are dynamically converting the types. Like, that will, like, reduce the performance at runtime.
Okay. I think in terms of performance, you're not going to get any particular benefit by using one or the other. Like, they both pretty much use the same mechanisms in order to like load a library, a shared library, and access shared objects. So you're not going to, the performance is generally going to be the same for shared, using the, the build mode shared version versus plugins. So I don't think that there's going to be any difference there.
But there is reflection we are using here to convert the type at runtime. But I guess in shared, like, it will be just linking before execution starts.
Yeah, this is actually not using like reflection at all. So here it's just returning an interface type. So like you don't actually have to reflect on any of the object types. You would this actually returns a real type. It just happens to have interface at this point, and you can just cast it. So there's not really any particular reflection penalty there.
Okay, thank you.
Yeah, no problem.
Anybody else? I think in any event, we're out of time. So we'll close the questions here. If you have any more questions, please feel free to catch Ian directly.
Yes, please do.
So thank you so much, Ian.